So in this example, we are asked to find the voltage across the 10 ohm resistor. And to solve for that, we will use Ohm's law and Kirchhoff's voltage law. So we need two things. So the first one, we need, of course, we need Ohm's law and KVL. Now KVL says that the sum of the voltage in a closed path should be 0. So let's start from here. And if I go around this loop, the sum of the voltage in this closed path should be 0. That's what we understand from KVL. So KVL, Kirchhoff's voltage law, says that the sum of the voltage should be 0. Now, if I start from the 35 volt, if you see we go from minus to plus. So we're going from negative to positive. So it should be minus 35 volts. Because KVL says that sum of the voltage should be 0. And the second component is a 10 ohm resistor. So we go through here and we're here. So we pass the positive side and go to negative. So we go from positive to negative. So if we do that, the voltage should be positive. So it should be plus, the voltage is given as Vx. So plus Vx. And now the third component is here. Again, now we're going from a plus to a minus. We're going this way. So if we go from positive to negative, again, it should be positive. And the voltage across that component is given as 2Vx. So we say 2Vx. Let me erase. And the third one is, sorry, the fourth one, or the fourth component is the 5 ohm resistor. Let's say that the voltage across the 5 ohm resistor is V1. If we are going from, well, in resistors, we go from plus to minus, it goes like this. So across the 5 ohm resistors, we go from positive to negative. So it should be plus, it should be 0. That's one thing. So there are 4 components. The sum of the voltage across these 4 components should be 0. So the first one is minus 35 plus Vx plus 2Vx plus V1 equal to 0. So good. Let me erase these parts. Now we have, so we have the KVL that goes this way. And let's say we say that this is V1, we assign plus and minus. Of course, if I have a resistor, if the current is going this way, always this is positive and this is negative. That's true for resistor. If the current is going like this, then the voltage should be positive to negative. It's always true. That's why here I just put this as a plus and this one as a minus. I'm assuming that the current is going this way. So if the current is going this way, then this should be positive, this should be negative. That's one thing. Now let's this current say I. And this current, or the current through this one, let's say is also I. If I use Ohm's law, right? If I use Ohm's law, what do you see? Vx, or the voltage across the 10 ohm resistor, is equal to 10 times I. So if I say the current through this one is I, So Ohm's law says that the voltage across the resistor is equal to the current I times the resistance. V equals to I times R. Now the voltage is Vx, I is the current and R is the resistance. Now in this specific case, the resistance is given. We know the resistance, right? So the resistance is 10 ohm. So I'll say R is 10. So this will give me 10I. What about the second one? In the second resistor, of course, the current is going this way. I said this is plus and this is minus, and we denote that the voltage is V1. It's just we labeled that as V1. So V1, or the voltage across the 5 ohm resistor, is also equal to the current I times the resistance. Now in this case, the resistance is 5, right? So this is 5I. So Vx is 10I, V1 is 5I. From this, now we have the relation between Vx and I. So therefore, what we need is, we'll substitute these two values, or these two expressions, in the KVL equation. So in the KVL, we have minus 35 volt plus Vx. Now Vx is 10I plus 2 times Vx, again 2 times Vx. Vx is 10I plus V1. V1 is 5I. That should be equal to 0. Right? Of course. Now we have 10I, 20I, and 5I. If we add all these, this becomes minus 35 plus 35I should be 0. So therefore, if you rearrange this, I will be 35 over 35, which is 1. And the unit for the current is amps, so it will be 1 amp. It will be 1 amp. So the current is 1 amp. Now we determine I. Now the question is, find the voltage across the 10 ohm resistor, or in other words, Vx. Now I is 1 amps, so what I will do is, so let me erase, or let me write it down on this side, so that you can compare everything. So now we are asked to find Vx. Vx is 10I, but now I is 1. So 10 times 1 is 10. So 10 volts. So Vx is 10 volt, the voltage across the 10 ohm resistor. Similarly, if we want to find the voltage across the 5 ohm resistor, which is V1, that is also 5 times I. I is 1. 5 times 1 is 5. So it will be 5 volt. So 10 volt and 5 volts are the answer for this question. Okay, let's go to the second example. In the second example, we are asked to find the voltage across each component. Okay. So we want to find the voltage across the 2 ohm, the 8 ohm resistor, the 6 ohm, and also the 4 ohm resistor. Let's do this example together. Now let me say this is A, and let me say this is B. So let's start with A. So in this case, we need Ohm's law and KVL or KCL. So we need this to solve this problem. So let's first start with A. So for A, what we'll do is first we'll determine the node. How many nodes we have in this network in figure 1. We can see that we have one node here on the top and one node here at the bottom. So we have two nodes. It is similar to what we saw earlier in the other video when we discussed about nodes, loops, and branches. So here we have two nodes. Let's say this is node. Let's say this is node 1, and this is node 2. So we have two nodes. So KCL, the Kirchhoff's current law, says that the sum of the current at any node should be 0. So let me redraw that figure. So this is node 1, let's say. Now 6 amp, so this is 6 amp, enters to the node. And the other one is I0 or I0 is leaving this node. We have another component which is again leaving. That's a dependent current. It's I0 over 4. And we have the force component on the other side. Let me assume that is also leaving. Let me say that is I1. Now this is an assumption. If I am correct, the answer will be positive. If I am wrong, the answer will be negative. That's the only difference. So let me assume that the current through this branch is going. So I1 is leaving. So that's an assumption. So you are free to choose the direction in any way. It doesn't matter. If your answer is correct, the answer will you'll get a positive answer at the end. If the assumption was wrong, the direction was wrong, then just the only thing that changes is the sign. Magnitude remains the same. It wouldn't change. So now KCL says that the sum of the current at any junction should be 0. So now 6 amp enters, so it should be positive. So 6 amp. I0 is leaving, so minus I0. And the second component is also leaving, again minus I0 over 4. And the third component is also leaving, minus I1, should be equal to 0. Of course, okay. So what we have is, if you add all these, it will be 6 equal to 1 plus 1 over 4 is 5 over 4 I0 plus I1, of course. Now in this case, we have two unknowns and one equation, so we can't solve this problem unless we have a second or additional information. So to get that additional information, what I will do is I'll just use KVL. So let's consider, so the current is, we said is going this way, so it is plus minus. It's I1. Let's consider this loop. Let's consider this loop. Now KVL says that the sum of the voltage in a closed path should be 0. Now we have two components, right? We have two components. One is the 2 ohm resistor and the other one is the 8 ohm resistor. So if I redraw these two components, I have one here I have another here. Right? That's what it means. Let's say this is plus minus, and the voltage across this one is, let's say this is V1. This is also plus minus, and the voltage across this one is, let's say, V2. KVL, or the Kirchhoff's current law, says that the sum of the voltage in a closed path should be 0, of course. Then for that reason, I have this. So therefore, if I start, let me use a different color. So if I go around, this, what I will get is, if you start from here, we go from plus to minus. So plus V1, which is positive, minus, we're going from minus to plus, minus V2 should be equal to 0. That's what we'll get. Or V1 equal to V2. V1 equal to V2. Now what is V1? V1 is the voltage across the 8 ohm resistor. We said the current is I1, right? The current is I1. So V1 is 8 times I1 if I use Ohm's law. And V2 is the voltage across the 2 ohm resistor, which is 2 times I0. If you use this, I1 will be 1 over 4 times I0. So now we determine the relation between I1 and I0. I can use this relation to simplify this one. What I did was I used Ohm's law to determine V1 and V2. So for V1, I have 8 ohm resistor, and the current is I1. So I said V1 is 8 times I1. For the V2, I had the 2 ohm resistor, and the current is I0. So V2 is 2 times I0. We use this. So this is using Ohm's law. So we use V1 and V2, and we substitute that with 8 times I1 and 2 times I0. Now we find the relation. So I can use this and substitute that back to this. Let's do that. If we do, what do we get? This will be 6 equal to 5 over 4 I0 plus I1. Now I1 is 1 over 4 I0. So if you add this, it will be 6 over 4 I0 equal to 6, and I0 will be 4 amps. I0 will be 4 amps. And if I know I0, I can determine the others. If I know I0, I1 will be 1 over 4 times I0. Now I0 is 4, so I1 is 1 amps. So we determine I1 is 1 amp, I0 is 4 amp. So if we know I1 and I0, then we can determine all the values. So I1 is here, it is 1 amp, and we determine I0, which is 4 amp. Now the question is, find the voltage across each resistor. So the voltage across the 2 ohm resistor is I times R, which is 2 times I0. Now I0 is 4, 2 times 4, which is 8 volt. The other one is the voltage across the 8 ohm resistor. If I want to determine the voltage across the 8 ohm resistor, I'll just use V equals to IR, or Ohm's law. The resistance is 8, so this will be 8 times I1. The resistance is 8, I1 is 1 amp, 8 times 1 will give us 8 volt. So it turns out that the voltage across these two components is the same. So we used, to solve this problem, we used KVL or Kirchhoff's voltage law, KCL or Kirchhoff's current law, and Ohm's law. We used all these three to solve this problem. I hope you can use this to solve the second problem, which is, let's say this is A and this is B. Now in the second case, for part B, we have, the first thing is we have to determine the junction. So we have one junction here. And we can use that junction to write the KVL and the KCL. Let me just clear this. So we're doing the part B. So in this case, let's start with this node. Let's say let's label this is node 1. So our goal is write the KCL. So our goal is write KCL at node 1. If I redraw that at this node, we have three branches. One is the 10 amp that enters to this node, and the other one is the 2 times V0 current source that comes this way. Keep in mind that this is a current source because we have arrow, and this is also current source. That current value is 2 times V0. So the diamond shape shows that is a dependent current source. Its value depends on one of the component. In this case, this current depends on the voltage across the 4 ohm resistor. So that's why we have 2 times V0. But still it is current source. So this current enters to this side, this current enters to this side. And the third one, so this is a second. So the third one is this one. Let's assume. It's not given, let me assume. Let's say that is I1. And I1 is leaving this node. So this point is node 1. So 3 currents, we have 3 branch currents. The 10 amps and the 2 V0 enters, and I1 is leaving. So if you write the KCL, I1 is leaving, so it should be negative, so minus I1. The 10 amp enters, so it should be positive 10A, plus 2 V0 enters, so it should be 2 plus V0 should be equal to 0. Now, just like we had in the previous case, here also we have 2 components, 2 unknown components, I1 and V0. And we have only one equation. So to solve this equation, so we have to find an expression, I1 in terms of V0 or V0 in terms of I1. Okay. Now, in order to find the relation between I1 and V0, we'll just consider the 4 ohm resistor. So for the 4 ohm resistor, what we have is, let's say, so this is 4 ohm, is plus and minus, and the voltage is V0. Now we know that, let me just use a different color. So we know that the current goes from positive to negative through the resistor. Let's say this current is I. So therefore, using Ohm's law, right? So if I use Ohm's law, we can see that V0, or the voltage across the 4 ohm resistor, is equal to I times R. The resistance is 4. The current is I, so it will be 4I. So we can say that this is V0 equals to 4 times I. But our goal is to find the relation between I1 and V0. Well, now what is the relation between I and I1? let me just use the green color. So I1 is the current that goes this way. So this is I1. So this is I1. Now, if you see the relation between I1 and I is, of course, they both are just labeled currents through the 4 ohm resistor, but in opposite direction. So we can say that I1 is equal to minus I. So we can use this relation and substitute back in terms of I. So if I substitute that, so it will be 4 times I, but I is equal to minus I1, so this will be equal to minus I1, right? So I equals to minus I1. So if you do that, what we'll get is V naught equals to minus 4 times I1. That's it. So this is the relation between V naught and I1. Now we can use this to solve this expression, the first expression. So what I will have now is, let me just use the previous block. So now what I have is minus I1 plus 10 amps plus 2 times V naught, but now V naught is minus 4 times I1. This is equal to 0. Okay, so now I1 will be 10 over 9 amps. Okay, therefore, so now we determine I1, which is the current through the 4 ohm resistor. So the question is, we're asked to determine the voltage across each resistor. So the 6 ohm resistor is here, and the 4 ohm resistor is here. So this is I1. So I1 is the current that goes through the 4 ohm and the 6 ohm resistor. So the voltage, so therefore, the voltage across the 4 ohm resistor is 4 times I1, which is I1 is 10 over 9, so it is going to be 40 over 9 volts. And the voltage across the 6 ohm resistor is also 6 times I1, which will be 60 over 9 volts. So the true polarity is plus minus. So the true polarity for the voltage across the 4 and the 6 ohm resistor is plus minus. So according to this, V naught is 4 times I1. So this is 4 times I1 is 10 over 9. So this is minus 40 over 9. V naught is minus 40 over 9, which is true because V naught is labeled as a plus minus, which is opposite to the voltage, which is opposite to the polarity of the voltage across the 4 ohm resistor. So V naught is minus 40 over 9 volts, whereas the voltage across the 4 ohm is 40 over 9 volts. So they have the same magnitude, but there is opposite polarity. So with this, we end solution with this example.